Good afternoon, everybody. How are you all? Today we are going to talk about standard normal scores. So I'll share my computer screen with you. A student took two national aptitude tests. The national mean and standard deviation were 475 and 100 respectively for the first test and 30 and 8 respectively for the second test. The student scored 625 on the first test and 45 on the second test, in which test the student performed relatively better. Okay. So, solution. Now, as you notice, the two tests have different means and standard deviation. So you really cannot compare them because different means and standard deviation. So the best thing is to calculate the standard normal score for the student score in the first test and in the second test. Okay, so solution. Calculate Z, which is standard normal score or standard normal variable for the students' performance in each test. In each test. Now, Z, the standard normal score, is given by this formula. How far the number deviates from the mean, the difference is then divided by the standard deviation. That is why it is called a standard normal score. It is as if we are finding out how many standard deviations above or below the mean is a particular score or particular X score. So for the first test, Z, the student scored 625 on the first test and the mean was 475 and the standard deviation was 100. So Z is equal to, first we will do 625 minus 475, which is 150 divided by 100. So Z is equal to 1.5. What does it mean? It means the student score of 625 is 1.5 times standard deviation above the mean. Why above? Because the number 625 is greater than the mean, so it is on the right of the mean. So 1.5 standard deviation above the mean. Okay. So again, we are calculating the standard normal score for each test because it will help us to compare the student's performance in both the tests with different means and standard deviation. So for the second test, again, Z is equal to X minus mu divided by sigma, right? So that's the definition of standard normal score. So Z is equal to, his score was 45 and the mean was 30 for that second test with a standard deviation of 8. So Z is equal to how far the number 45 is located above the mean divided by standard deviation. So Z will be how many standard deviation above the mean of 30 is the number 45 located. which is 15 is the difference divided by 8. So 15 divided by 8 is 1.875. So it means the student's score of 45 is 1.875 times standard deviation above the mean. Above the mean. So if I draw a number line, just let me create some space. Okay. So this is a number line. Let's say 0 is over here. So the first score is 1.5. Okay. So let's do first. This is 1 and this is 2. Okay. So 1.5 is, let's use a different color. Let's use probably I'd be better off using green. Okay. So the first z-score is 1.5, which is somewhere over here. This is z-score of 1.5. Z-score of 0 is the mean. Z-score 0 is the mean. Okay. So the first score of 625 is 1.5 standard deviation above the mean. Okay, what about the next one? Next one is 1.875. So that is more closer to 2. So again, if I change the color of the ink, what color should I select? Okay, maybe I'll select this color. Okay, okay, so 1.875 is more close to 2. So somewhere over here is 1.875. So this is your 1.875 and this is your 1.5. So this shows clearly since 1.875 is greater than 1.5, the student's relative performance with respect to the mean and the standard deviation, relative performance was better in the second test because his z-score of 1.875 is greater than the z-score in the first test, which was 1.5. I will stop here today. If you still have question or comment, please write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. And if you like this video, please share this with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner of the screen. I'll see you next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time.